All right, welcome to another day of logarithms. Today we're having class outside. I hope you're enjoying the beautiful sunshine. We're going to look at the properties today, and it's important to know the properties in and of themselves. We're going to practice how they work, but really they're helpful when we get to solving equations with logarithms. So what we do today is just kind of a middle ground type of exercise to get to the point where we'll use them down the road, the next class or the one after, in solving with logarithms. So they come into play there. So we're going to start with, and these are things that you are sort of we are trying to lead you to kind of discover these. Now I'm going to explicitly tell you, again, this should have parentheses around this, and this should have parentheses around this. And this n is just on that m, so the parentheses would be there. So notice that these things are all being applied to what's inside of the individual logarithm. So the product property is implying that these two values or terms inside the log are being multiplied. And if that's the case, I'm allowed to rewrite this as log base b of m plus log base b of n. So if two things are being multiplied in a log, I can write it as two separate logs. Notice the base has to stay the same. And I just want to, I'm going to do this for each one of these. There's a little thing that we already know about exponents. If I had given you x to the m times x to the n, so again, there's a product happening, you would have added those exponents. Oh boy, that does not look like adding to me, so I'll kind of fix that so make sure we're reading it as adding. But this property is, again, remember, we think of logs as exponents. So I've got basically multiplying going on, so I can add. This would be m plus n. That's a little better. All right, so same thing with the quotient. If I'm dividing two terms inside of a log, I can represent that as two separate logs. I'm maintaining the same base, but again, multiply goes to addition. And division is the opposite of multiplication. What's the opposite of addition? It's subtraction. So I can write this as two separate logs. And again, these are just going to help us solve a little bit later down the road. And these go both directions. If I had two separate logs being added with the same base, I could simplify it to a single log using multiplication. And again, this goes back to the idea that if I had x to the m over x to the n, that equals x, and I'm allowed to subtract those exponents. So similar idea. And now we got a power outside of my log. Remember, if we think of this logarithm as a power, an exponent, if you have an exponent and another exponent, the rule with that, and I'll do that first, if I had x to the m raised to the n, power to a power, you guys did this a bit last unit, you would multiply those two together. So this is the same idea. This is my favorite one. And what happens is I am allowed to take this exponent that's being applied to what's inside my log, and I'm allowed to drop it in front of my log as a regular term, and then multiply that by log b of m. So those are the three properties. We already did change a base a little bit last class. That's another property. Now I'm going to kind of show you where these come into play. I have one correction I have to make on my paper, and that is that this b here should be a 4 so that it matches that 4, and these all match. So the bases have to be the same for these properties to work. So in this case, I'm telling you what the log base 4 of 3, it's approximately 0.8. It's not quite 1 because log base 4 of 4 equals 1, or log base 3 of 3 equals 1, so it's close but not quite. And log base 4 of 7 is just a little bit over 1. So we're going to use these approximations and the properties we just talked about up above. So here I've got log base 4 of this 3/7, which really should be in parentheses. And I'm allowed to then say, oh, well, that's log base 4 of 3 minus log base 4 of 7. Because two things are being divided, I can write it as subtraction. And if that's the case, I already know what log base 4 of 3 is. It's about 0.8. This expression is approximately 0.8. And this expression right here is approximately 1.4. And so I can put in my approximations for those two values, and I can get an answer of negative 0.6. As it were right here, I have no idea what power of 4 would yield 3/7. it's not given in my key up here. I could type in a calculator, but using this as a guide without a calculator, I could solve this problem. Similar here, it's a little bit more challenging because it's not quite as obvious, but I need my log for base 4 to be written in terms of 7s and 3s and or 3s. And so when I see 21, I want to think to myself, well, that's the same as 7 times 3. So this is really the same as saying log base 4 of 7 times 3. And if that's the case, there's a multiplication in there. I can rewrite this as log base 4 of 7, plus log base 4 of 3. Multiplication in my log, write it as 2 separate logs being added. And again, I've got my substitutions I can play around with here. Now I already know log base 4, 7. That's about 1.4. So this expression is 1.4. This expression over here is approximately 0.8. And if I add those together, I should get 2.2, I believe. All right, last one. Same initial step is the tricky one, and that is, I don't have a 49 up here, but 49 is a power of 7. So I could write this as log base 4 of 7 squared. You could also write it as log base 4 of 7 times 7 and do what we just did right here. But I want to highlight this property because once I have an exponent up there, that exponent I'm allowed to drop in the front, so that 2 drops in front, times log base 4 of 7. So the exponent becomes just a regular multiplier. I already know log base 4 of 7 is about 1.4, and I throw that together and get 2.8. All right. Now we're going to literally just practice these properties, expanding them first. So the directions are important. This wants us to expand these logarithms, which means I want to go from a single log and write it as multiple logs. So in this one, I have division. So I would expand that by writing it as log base 4 of x minus log base 4 of y. So it's really just practicing knowing division in a log can be written as 2 logs being subtracted. All right, you try this one. Log, and there's no base down here, so that's the common log. What would this be? Pause it. All right, if you expanded this, is multiplication happening in there, so I could write that as log 9 plus log y. And I don't have to worry about writing the base because it's base 10. This one gets a little trickier, so we'll do this in pieces. I've got 6x divided by 19 in log base 3, so I could go, oh, easy. Log base 3 of 6x minus log base 3 of 19, and I'd be all content with myself, except inside of this piece there's 2 things being multiplied, so I can expand this one. This multiplication can be written as log base 3 of 6 plus log base 3 of x, and then this subtraction piece is off to the side. So there are 3 pieces to that, and that's okay, we can do that. Notice here also 3 pieces. Take a second, pause this video, try to expand this one. All right, again, 3 pieces, all of them being multiplied, so I can just write this as 3 logs, and I could, if I was really cruel, just give you tons of things inside of a log and ask you to expand them, and it could be however many operations were going on in there, you could have to be forced to expand those. All right, moving to the next page, similar idea. You can't read these directions, but it says use the product quotient and power properties to expand. So the only thing I've done here extra is I've added powers in here. So this one I've got 2 things on the top and something on the bottom, so I'm going to do this in steps. First thing I would do is put that 5x cubed and subtract log base 6 of y. Now this piece is done, but I'm not done here because these 2 pieces are being multiplied, so I could expand that to log 6 of 5 plus log base 6 of x cubed, and this part here is just going to linger and hang on. And then finally I have one more step I can do because I have an exponent up here, and so that is allowed to drop in front of this, so I can rewrite that by just moving it into the front, and that is my answer. You're going to try it with this one. Pause the video, give this one a go. All right, video's on pause. You should have gotten log 3 plus 4 log x. These are being multiplied, so I go to add, and the exponent that was on the x, that is only on the x, so it drops only in front of the part that has the x. Finally, we're going to finish this off. We only have a few more examples to go. we're going to do this process backwards, and then we're going to be done. So notice on these, I want the directions to write everything as a single log. And as it is, everything is currently written as more than one log. They all have the same base. That is critical. So this one has an addition between two logs. So I can rewrite that as a single log, because that's my directions, one log. And in the parentheses, I can put these two numbers, but I would multiply them. It's exactly backwards of what we were doing up above. And I actually know what 5 times 10 is, so I'm going to take the extra step and go, that's log base 3 of 50. All right, you give it a try on this one, noting it's subtraction. Pause the video, try it. All right, on this one, an answer, and I'll show you in a minute, but you should have gotten log base 4 of 5. That should have been your answer. And the reason is subtraction allows me to write this as a single log, putting 15 divided by 3. Subtraction means I can write it in here as division, and I actually know what that equals. That equals 5, so I could simplify that. Can't always, in example 11, I can't simplify if there's an x in terms of something like I could do 5 times 10 to get 50. When I put this together, I'm just going to have to answer, I'm going to have an x in my answer, and that's okay. So first thing is very important. If you have a number out in front of your log like this, I have to deal with that first. This is like your order of operations. Remember, that is being multiplied, this is being added, so I have to deal with that first. Backwards, number out in front means I can write it up here as an exponent. Again, that's just the opposite of what we were doing a second ago. And the reason I'm doing that is I want to write this as a single log, so I want to compress this all together into a single log. Now I have log base 6 of x squared plus log base 6 of 8. Adding means I can write this as a single log. And I would take the 8 and the x squared, and I can multiply those together. And so I would have 8x squared. That's it. Done. You try it with this one. Be careful. There's a number in front, and that's subtraction. Pause the video. Try it. All right, here we go. Again, this would be your first step, popping that up there as a power. That isn't there anymore. Gone. And now I've got log base 7, and I have a subtraction, so I have to write this as division. That's the top. This is the bottom. And that would have been your answer. I don't know what z and x are, and so I just leave it like that. And again, we are literally just practicing what these properties do. Next unit or two, or next lesson or two, we're going to put equal signs in equations, and we're going to be solving these equations. So have a good day.